Hey everyone, welcome to The Explainer. Today, we're unpacking a massive rite of passage. I mean, it's something almost every single first-time open source contributor eventually hits. You put in the work, everything feels perfectly fine, right up until you try to actually share it. And bam, you hit this totally confusing, frustrating wall of merge conflicts. Yeah, we're talking about the hidden cost of stale forks. By the time we wrap up today, you're going to have a rock-solid mental model of what's actually happening behind the scenes and the exact routine you need to fix it for good.
Okay, let's dive into this. Here's our roadmap for today. We'll start with the stale fork problem, then look at the anatomy of a fork, contrast origin versus upstream, get into fetching, compare merge versus rebase, and finally, we'll build the complete sync routine. So, part 1, the stale fork problem. It's the frustrating wall every new contributor hits. Imagine this scenario. You fork a repository, you spend weeks writing some absolutely fantastic code, but when you go to open your pull request, a reviewer asks, why is your pull request 50 commits behind main? Or maybe your fix just won't apply cleanly, and there are these phantom conflicts that nobody can quite explain. If you've ever stared at a screen thinking, wait, why is my pull request 50 commits behind main? Honestly, take a deep breath. Experiencing this frustration, it doesn't mean you wrote bad code. No way. It simply means your fork went stale. And, well, nobody warned you that this would happen. And when that confusion hits, it is incredibly tempting to rely on some pretty desperate workarounds. Maybe you just force push over the problem, hoping it goes away. Or you delete your entire branch and start completely over. Some folks even resort to the ultimate walk of shame, literally copy-pasting their changes by hand into a fresh clone. Look, while those tricks might technically get you unstuck in the short term, they don't teach you anything. You're virtually guaranteed to hit the exact same mysterious wall on your next PR, just in a slightly different disguise. We need an actual, permanent fix. To find that fix, we go to Section 2, Anatomy of a Fork, Why Your Code Falls Behind. So we need to look under the hood at what a fork actually is. Because when you fork a repository on GitHub, you're not creating a live, breathing engine connected to the original project. You're creating a snapshot. Think of it like a block of ice. It's a full copy of the repository sitting under your own account, but it's completely frozen at the exact moment you clicked that fork button. From that second forward, your fork and the original project, they're two totally separate entities that just happen to share a history up to that specific moment. And right here is where people get tripped up. The original project doesn't just pause and wait for you to finish your work. Other contributors are still out there, merging pull requests. The maintainer is pushing fixes. So a few weeks later, the original repo might look completely different, but your fork, it doesn't update itself. It just sits there exactly as you left it, and a gap tears open between your frozen snapshot and the real project. That growing gap is exactly what we call a stale fork, and it's the true culprit behind all those confusing merge conflicts. Moving on to Section 3, Origin versus Upstream, Understanding Your Remotes. To keep a fork fresh, we really need to talk about remotes. A remote is just Git's way of referencing a repository that's stored somewhere else. When you clone your fork to your computer, Git automatically sets up a remote named Origin. Think of Origin as your own private house. It's your personal fork on GitHub. But your little house doesn't know anything about the original bustling project factory. To pull in changes from the real project, you have to explicitly add a second remote. The universal convention is to name this factory Upstream, and this brilliantly illustrates the core dynamic. Upstream is theirs, Origin is yours. Almost every confusing fork problem traces back to a developer simply not having that upstream remote set up, which leaves them with absolutely no way to ask Git what the real project looks like right now. Which brings us to Section 4, Fetch, Looking Without Touching, or Safely Checking the Gap. Once you finally have your upstream remote configured, you need to know how to check that gap. And you do this with a command called git fetch upstream. Now, fetch is kind of like pulling out a pair of binoculars. It simply downloads the latest history from the upstream project, every commit, every branch, right into your local repository, but it does not change any of your own files. It's looking without touching. You're observing from behind a protective shield. It's purely informational, quietly updating Git's internal picture. So it's a completely safe command to run constantly, because it literally cannot break your work or create conflicts. After fetching, you can see exactly how many commits you are missing. No more vague feeling that something is off, you get concrete data. All right, Section 5, Merge versus Rebase. 2 ways to actually catch up. Now, fetching tells you what changed, but it doesn't bring those changes into your branch. To actually catch up, you have to make a choice between merging and rebasing. Let's contrast them for a second. Merging combines changes by stitching the two histories together into a brand new commit. It's an honest history, nothing gets rewritten, making it a super safe default. Rebasing, on the other hand, takes a totally different approach. It's kind of like cutting and cleanly restacking blocks. It temporarily removes your commits, updates your branch to match upstream exactly, and then replays your commits one by one right on top. It gives you a beautifully clean linear history, making it look like you started all your work today. But it does rewrite commit history, giving your commits entirely new identities under the hood. Because rebasing rewrites history, it makes a lot of new contributors really nervous. But here's a practical rule of thumb that honestly solves that anxiety entirely. Ready? Rebase freely on branches that are still a private walled garden, meaning they only exist on your own fork and haven't been shared with anyone yet. However, once you share a branch and others are building on top of it, use merge. If you rewrite history out from under a collaborator, it's like knocking over their tower of blocks. Your copies will disagree in a genuinely painful way. So just stick to this rule, and your collaboration stays safe and totally conflict-free. Okay, let's move to section 6, the complete sync routine. Let's piece all of this together into an actionable workflow you can use today to fix this for good. This is the exact routine you should run before you start any new piece of work. Step 1. Fetch upstream changes so Git knows what's out there. Step 2. Merge those upstream changes into your local main branch, which catches your local machine up. Now, pay super close attention to step 3, because it gets skipped all the time. Push that updated local main back up to origin. Remember, fork syncing has to happen in 2 places. If you don't do this, your GitHub fork stays stale even if your local computer is perfectly up to date. Finally, step 4, check out a new branch for your actual work. Do this, and your new code is built on top of the current project, not some frozen snapshot from 3 weeks ago. I absolutely love this quote from our source material on this. Once this mental model clicks for you, managing stale forks stops being this mysterious source of PR-breaking confusion. It just becomes a 2-minute maintenance step you do without even thinking about it. Quote, the same way you check your car's mirrors before pulling out, not because it's hard, but because skipping it is where the actual trouble starts. It's so true, right? If a conflict shows up later, it'll be a real, meaningful conflict about the code, not a phantom error caused by starting from stale history. So we've broken down the snapshot nature of forks, the absolutely critical difference between your origin and the maintainer's upstream, how to safely check for updates with fetch, and how to permanently adopt a sync routine that protects your hard work. Which leaves us with one final thought. The next time you sit down to contribute to an open source project, will you remember to check your mirrors? Are you ready to confidently sync your fork today? Thanks so much for joining me on this explainer, and happy coding!